economic processes supported by computing servers and software is also increasing. So for modern large IT structures, a variety of technical and methodological solutions can be used to implement effective access control. However, the diversity of platforms and tools that are being used, as well as the number of influencing factors, significantly reduce the effectiveness of access control and increase the risk of cyber threats. So the purpose of our research aims to improve the efficiency of managing the access control system components of IT infrastructure by developing a methodology that combines modern tools and methods for analyzing data and states of information systems to determine the risk level of the access control system. It's our general purpose and some more specific objectives of the current presentation to develop the foundation of the methodology and demonstrate its core working logic, conduct a limited mathematical experiment, and highlight the benefits of applying this methodology and the potential of improving access control systems. So our methodology. The main stages of the development methodology are the follows. Identify the subjects and objects of the IT structure that is being evaluated, and then describe these entities and their interactions using factors that influence the risk assessment and granting access. And then to establish the values and levels of these factors, ranging from 3 to 5 levels each. And then to define the interaction rules and the factor influences with the help of relevant experts, standards, and different frameworks. To perform calculations using fuzzy logic inference, and to assess the risk of granting accesses, which will help improve the system. Here you can see the general concept of our testing methodology. So how it's work, a few words about it. First, it's necessary to understand that the interaction scheme between subjects and objects within the framework of the accepted access policies for the structure. Other data for the factors and their levels obtained from the specifics of the IT structures, design, and different relevant standards. And data of the descriptive factors will be collected using widely used anti-infrastructure monitoring and management tools such as SNOT, Wazoo, UEBA, so on. Experts establish the values of the factors and some interactions rules using databases and libraries for network management and cybersecurity, such as CVE or SCAP. Access control system evaluation. We propose to evaluate the subject based on the complexity of the password and authentication, which collectively provide the access management level. Next, we describe the object in terms of how frequently it is needed, the sensitivity of the information, and the level of object influence or dependency here in this group. We also describe the interaction between the object and the subject using factors such as level access and privileges, the type of network, uh, the potentiality of possible attack vectors, and exploit maturity, and so on. We conducted simplified testing of the methodology with a limited number of factors to verify and demonstrate the logic of factors interactions and the applicability. Here is the scheme of influence of indicators in our simplified experiment. And here you can see the example of some linguistic variables and outputs for risk assessment. Additionally, there are some rules examples. And the result, as a result, we obtain the risk level fuzzy output, which essentially shows the potential risk levels within the access control system based on different combinations of access management and password management settings, as well as access level and privilege risks. As a conclusion, I can say that by combining modern network control tools and up-to-date vulnerability libraries and using cutting-edge technologies based on fuzzy logics and comprehensive analysis of IT infrastructure, we achieve a more objective and effective risk assessment. This combination is superior to other existing approaches and methodologies or analysis that lack any of these components. It's only the beginning of our research. The further directions of it can be connected with enhanced risk assessment. To integrate advanced tools and fuzzy logic for improved risk evaluation. Then system improvements, adaptability and AI development, and expanding metrics. It's possible to explore using a broader set of indicators to assess IT structures per international standards. Thank you for your attention, and thank you again for me to be able to present this work.
Thank you very much. Please, somebody have questions maybe to report. Yeah. If nobody want, I must ask how to compare your system of control, access control, for example, for GCP, Google Cloud Platform has quite advanced system of control system. And do you take into account that some access has hierarchical level of access? Somebody have much more access than another people, small part of access of another one. Do you understand? Hierarchy of access.
Yeah, sure. We take, of course, we take into account different roles and different access levels. It's one of the main parameters of our system.
And how is roles with access interconnected? How depends access from roles?
Sorry, I didn't get it.
When somebody fulfills some roles, and access depends from roles, and are present in your approach dependence access from roles. Access depends or not depends from roles of each person who want to obtain access, or service who want to obtain access.
Yeah, we have if even a bunch of parameters connected with the rules that customers have, the users have, and their privileges and so on. So we take it into account as an input factors.
You cannot see here roles. Okay. And in previous slide, you showed many software previous is no. One of first slides. Software for here.
This one.
Snort, Fuzzer, federated learning, and so on. All there's maybe have API, or maybe have not. How it is taken data from this very different software to obtain and give them permissions and so on, access control.
Yeah, it's actually one of the main task in all this system to take the data from all these different researchers, especially taking into account that we work in a large group of different companies, and we really have such problems with and we are in progress of solving them. Yeah, no, really not all the tools have its API, and some of them write some logs, and we can take from them. Some of them have handy API. Some of them, well, yeah, it's very software specific answer for this question.
Data, input data. Okay, it's interesting, very interesting picture, and we need to analyze more deeply physiologic methodology in these rules. What language was used for building the rules, and what inference, fuzzy inference was implemented.
Yeah, we're using MATLAB at the moment to build this prototype.
Okay, understand. Okay, thank you.
Yeah, thank you.
If no one have a question, thank you again. And we are going to next report.